Okay, let's talk about chemical bonding. Now, this is all about how elements in the periodic table bind together to form compounds. Look at a copy of the periodic table and you'll see every square has a chemical symbol with two numbers. So I've chosen lithium, 3, 7. What do those numbers mean? The 3 is counting the number of protons in the nucleus. So that's these red particles here. It's called the atomic number. And the 7 is counting overall how many particles there are in the center of the nucleus, in the center of the atom. This thing here is called the nucleus. And if we just lay those out next to each other, you'll see that the 3, again, counting the protons, which are positively charged, and the rest is made up in neutrons. So you can always figure out the number of neutrons by just doing 7 take away 3, or mass take away number of protons. So for instance, if we take these protons and neutrons together, that's known as the mass number. And if we take a look at the protons plus the electrons, we find that there's always the same number. And the reason for that is that the protons are positively charged and the electrons are negative. So you need 3 negatives to cancel out 3 positives. And you'll see that is the same in any atom, regardless of how many protons its nucleus has. So let's take another look at a different one. Let's do magnesium. This is 1224, telling us it has 12 protons, and also 12 neutrons. 24 minus 12, 12 neutrons, and of course 12 electrons to balance out the 12 protons. Now, if you count through these carefully, you see that the first shell holds 2 electrons, second shell holds maximum of 8, and the third shell also a maximum of 8 in magnesium. The third shell is not full, it only has 2. And remember, if you ever hear the expression of valence shell, that's just referring to the outermost shell, the outer shell. This is just a quick sheet to test yourself. If you want to go and get a copy of the periodic table, you should be able to fill all of these in. Just choose any element that's in the first 3 rows of the periodic table. Should fill these in nicely. You can download this on the website that's in the description below this video, by the way. So let's talk about ionic bonding. Suppose we have an atom of sodium on the left and an atom of chlorine on the right. Using the periodic table, we can figure out that there are what their electron configurations are. So sodium, looking at the table, we can see it has 2 in its first shell, 8 in its second, and 1 in its valence shell. Chlorine, we do the same thing. We find that it's 2, 8, and 7. It's right on the other side of the table, so it has 7. The rule with ionic bonding is that these atoms want to have a full outer shell. So you can see that chlorine really wants to gain 1 more electron. Sodium would like to lose an electron. So these are ideally paired. They can bind together if sodium gives this electron to chlorine, which is exactly what's going to happen. It's going to fly over there. And when that happens, sodium will become positively charged because it's lost a negative charge. It's lost a negative electron. Chlorine, on the other hand, will become negative because it's gained a minus charge. And so we now call these things ions, not atoms. So a sodium +1 ion and a chloride -1 ion. And because they have opposite charges, they will attract and stick to each other. And this is the basis for ionic bonding. They just stick by electrostatic attraction. Let's have a look at covalent bonding. So if you want to bond, for example, oxygen to hydrogen to make water, we've got a bit of a problem because hydrogen has 1 electron and it would like to have 2. Same with this one. It has 1 electron, wants 2. And oxygen also wants to gain 2 electrons to fill its outer shell. So everything wants to gain an electron. No one wants to lose an electron. So we can't use ionic bonding. But if they agree to share their electrons, this can work. And this is what covalent bonding is. We're going to overlap these shells and put pairs of electrons in. So 1 electron from the hydrogen, 1 electron from the oxygen. You have to have an electron from both. And what's happening now is that these 2 electrons are actually orbiting both atoms. They're orbiting both of these, and that's what forms the bond. Finally, we should talk quickly about metallic bonding. So in metals, they don't bond, atoms don't bond to each other ionically or covalently. They form a very different type of bond where the electrons are free to move about amongst the atoms. These are called delocalized or free electrons. And so the atoms just sit amongst this negative sea of negative charge, and that it's that ambient sloshing around negative charge that holds the positive nuclei in place.